Good evening, one and all. Welcome back to the data science program. So, in the previous session, we were looking at the decision tree as well as the random forest. So, one part of the ensemble learning is what we have seen. So, continuing with our regular discussions, we'll move on to the next technique. So, we basically have the SVMs and the KNNs and the boosting algorithms left. Okay, so I'll touch the SVMs and the KNNs at a later stage because implementation is actually has been done already. Correct. So in the yesterday's session, though we didn't know what exactly they do, but the implementation, the coding part, I actually have done because I didn't want to go when we cover the programs part of that. I don't want to take another data set and do it again. Anyway, you can just refer back to the yesterday's discussion, and the implementation part is very simple. You just have to instantiate that particular SVM and the KNN, and you can simply fit, you can make a predict and do that. So just 4-5 lines of code, correct? So that part we'll keep it aside, right? We'll touch the SVMs and the KNNs after we look at what is called as the boosting techniques. All right. So our today's topic will be. Okay, I'll just write it as.
Good afternoon, sir.
The boosting models. Good afternoon. Okay, so we'll be entering into a different types of ensemble over here. Again, you can consider this to be something like an advanced technique, and the boosting algorithms do work pretty much similar to the ensemble with some difference compared to the ensemble learning we learned in the previous section. That's the voting classifier, bagging classifier, etc. Okay, there will be slight difference. So always people think in a way that how do you improve once? Okay, so because again we saw that maybe the practical data set, whenever we implemented the voting classifier, bagging classifier, or any other ensemble learning, right, there is still a chance of improvisation, right? You can definitely try to improvise your model. So thinking that, keeping that in mind, what people always thought that how do you improve once? How to improve the model, right? So while thinking that, right, as a result of that kind of research, we have the boosting models now. Okay, so before going to the actual boosting models, I need you to recall something which we already have discussed maybe 1 or 2 times, because since it was pretty much important thing, I think we have discussed that few times already under the machine learning or just before the machine learning. That is all about it's about the types of data set, in what all format you get the data. Okay, so whatever you remember, either you give an answer orally or you please type in the chat box, please. What are the various types of data that we might encounter in a real world? Anything that you remember? Please go ahead. I'll start with the first one. Maybe that will cheer you up. Okay, so the first thing that most of us are using in any of the real-time data set, whenever we collect, it comes in either the tabular format. This is the first one, right? So tabular data. So even in yesterday's coding session, we use the tabular data. Okay, fine. So what are the characteristics of tabular data? If you remember, right, this is a most common one. That's the most common data type, right? So that's my first point. Okay, anybody wants to add any points to this? What are the other characteristics of tabular data?
It has rows and columns.
Perfect.
Like we can differentiate.
Okay, and what you get from those rows or columns? What are the columns, right? So columns will be either your features or whatever you want to predict, correct?
Yes.
Okay, so normally, okay, X is actually, this is how what the notation stands for. Okay, so X is the, I can write feature in the form of, okay, our features in columns. Maybe that's the best way. Anyway, Y will be the predictor. I will not write that. Okay, so most of the business cases are going to generate, are always going to be generate this kind of tabular data, right? So which month, how many items you sold, and what is the turnover, what's the loss, etc. If you try to make a right column wise representation, right, that's one of the examples. That's why I said most of the what you call the business cases are going to generate this kind of data set itself, right? Again, one of the very common thing. And as we can see some of the comments coming in the chat box, it says that, okay, Ruchi says that index, yes, row wise you can, if you want to address a particular row, or if you know the column names, yes, you are indexing that. Okay, again, right, you can have the data set that is present inside this, right, in the form of categorical or the continuous variables that can be present over there. So if you convert that into a data frame, right, that's using the pandas, you can you can handle it pretty much easy, right? So that's the one answer I'm getting. And other answers saying that Upkar says it is dependent in the sense, okay, a value in along a row, right, or your Y value depends on X. That's what the ultimate goal of machine learning, right? How they are dependent is what you're trying to find. Okay, I think that's what Upkar wants to say. Anybody else, any other points you want to add? Please go ahead. Meanwhile, I'll go to the next data type. Okay, so the next very common data type is the time series. Okay, all right. So is it a type of tabular? Can I call it? Can I call it as a type of a tabular data? Okay, maybe, right? Some of you will definitely agree.
Just a part.
Yeah. Okay. It's you can say that yes, right? But what's the difference? What's the difference between the regular tabular data and the time series data?
Time series data has a continuous variables, mostly continuous variables.
Okay. In the sense, can I say that the data collected
in a real,
yeah, at different
yes,
time intervals,
right,
different intervals of time. It will be interval in the sense it's a fixed term, like every second you collect, right? I have what you call maybe I have built up a circuit, and maybe mostly in terms of some processor or a control like Arduino or any DSP processor, Raspberry Pi, etc. You can interface various sensors to that, and you will say that every second or every 30 seconds, every minute, collect the values from the various sensors, like environmental variables like temperature, humidity, is it raining, water level, anything you can sense over there, right? So like that, if you fix a like interval and you collect that data from those sensors, the data set becomes a time series data. You can still write it in the form of a column, form of a table. Okay, day number 1, these are my variables. Day number 2, so it becomes the second row, but still you have the same time varying features. Then the day number 3, like that you can repeat for the whole year. So you have a 365 rows, so many columns. The number of columns will depend upon your sampling rate. Okay, you can make it every second. So in a day, how many seconds you have, so many columns will come. If you do it like, no, I don't want that, I want hourly basis, like every hour 1 reading. So then there will be 24 rows, 24 columns, 365 rows, like that. Okay. So you see that it's again a form of tabular data, you can say, right? If you don't want it to put it in a tabular format, don't say that it's a tabular format, no problem. But understand the meaning of the time series is basically dependent on time. Okay. Yes.
So, sir,
Yeah, go ahead.
is it like live data, or what's the difference between a live data and a time series data?
No, live data
Is there any difference?
No difference. Like if the live data is collected at regular intervals of time, it's the time series only, right? So basically, if since your question is a live data, yes, live data is also a time series, but I'll say that the time series is something which has a logical ordering of time. That's all. Live data definitely has. Okay, live data have it built in. You don't have to say that it's actually ordered in time, because first sample comes now, after some time the next sample comes in the live data, so you don't have to worry about the indexing in terms of time. But when I say that I have already collected it and I kept it in the time series format, you need to make sure that there is a logical time indexing, because first sample should be collected first, second sample should be collected after a certain interval of time, followed by the third. Okay, in that order it should come. So if you take care of, anyway, I'll write that point as well, so I can put it in brackets. So a logical ordering in time is required for this. Okay, I hope that makes it more clear, right? Okay, do you have any doubt? Okay, all right, so anybody? So I think that much enough for the time series. Can I go to the next one? How about image? What do you say? How this data set will be represented normally? What's a representation? Like table means you said that I have rows and columns. Now if I say image, right? Image, each point on an image is a pixel, correct? So you try to represent in the form of pixel, but how the machine is going to read? What format it's going to read, right? It's a matrix, again, rows and columns, right? So yes, that's right. So basically, the way of handling the data will be in the form of matrix, because it is easy to do the operations, right? Like matrix addition, multiplication, and transpose, and various other operations can be done very easily by using, right, a matrix notation. So matrix is a data structure that we use, but yes, it means as soon as I say matrix, it means, right, the data points are normally represented in the form of maybe I can write height into, there will be some specified width into, right? So what is this? Height into width is you are actually in terms of how many pixels you have. Like you say that 10 megapixel, right? There will be 10 million, right? And so on. So if I say 5 megapixels, so that is a 5 million points. Height into weight product is that number. Okay, and if you have a color, there could be something like the number of sensor channels. RGB, one example, correct? So you have 3 different colors captured by the sensor. So 3 different values will be kept, or while storing you save it 3 different matrices. But when you show it, you overlap them, right? By using some standardized technique, and you show that. Okay, so this is.
So there is no dimensions here, right?
What do you mean by dimension?
Like 1D, 2D, 3D.
No.
There is no dimension.
No, we are not talking about dimension here. So if you want to bring the concept of dimension here, if you say each layer, like height into weight, is like 2D, correct? So many pixels along the width, so many pixels along the height, that's a 2D. So you are repeating that 3 times, correct? Sensor will have 3 different layers, correct? So that becomes a 3D, right? Image is a 3-dimensional signal, if you want to talk in that aspect, but we are not bringing that over here. Okay,
so this is a basic one, basic
Yeah,
Good data point, right?
it means how many points you have, we are trying to collect that. That's all. So if you say 10 megapixel, your image, that's the height into width. That product is right 10 million into 3. So 3 such images are actually captured. One with the red channel, one for the green, one for the blue. So that's how it is. So the if you say 2 megapixel, that's the meaning. Okay, right? So
Okay.
can you convert this into time series? Is my next question. Is it possible? What happens if you collect images or the photos, right, with respect to time? So I'm actually moving my hand slowly, right? If you take if you take pictures of that continuously, right, and show it right on a screen, this becomes as I'm getting an answer. I think, yeah. So yes, that's right. That's a video, correct? So again, you see, image is actually one type. Again, I can convert that into another class of what you call data. The data format, it's called as a video. Okay, so I'll write the time series of images means you are generating another type, that is video. Okay, so yes, again you see that right on, if you are saying that I collect the what you call, I collect this time series of images, or I collect the video on a real time, means you can even apply, right, you can use this type of data set to build the real time vision tasks, right? Whatever is happening on a live screen or on a live location, you can try to track that, like somebody is wearing a mask or not, what's the distance between two people, right? You can make a calibration of your video camera, and on railway stations, airports, you see that, right? So uh, those cameras are calibrated to just to keep track that, okay, those two are having a separation of 2 meters or not, they can identify. Okay, so it's something like that. We call it as a vision task. Okay, so again, that's another very important this thing. Then nowadays there is another very important set of data. Okay, so that is the text data. What is the characteristic? How do you represent? Can you make it a table out of it?
Sir, if you made table out of it, then it will become a tabular data, right?
No, my question is that will you store it in the form of table or not? Is my question. So yes or no?
I guess no.
No, right?
Oh,
So
we can.
okay, so we can means, can you give example? Where do you store the text data in the form of table? In the sense, every character you store as in the form of a column, or what do you do?
No, 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 no.
Text is a different data. Okay, so it's normally we don't write it in the tabular format, but if you are, again, it comes from the business case, or if what is your application, something like I have say I want to look at the polarity of the reviews written on a product. So the complete text written as a review can be put up in one location, in one column. Okay, right? And next to that, you can write another column saying that it's a positive comment, this is a negative comment, this is a neutral comment, like that. You can make a column. If you write in that way, again, that's, as I told, it's a business perspective, right? What is your intention? Depending on that, yes, you can still write it, but in a normal way, right? The text data consists of array of characters, all right, or you can say strings. Even string is going to work fine, plus, right, maybe you will put numbers over there, right? It's a mixture. So that's how it is. What is the application? What nowadays, if you see, as the machine learning, deep learning, and the data science is in boom, right? You can see that there are various applications based on the language tasks is what is the is right is the first thing, right? Normally, depending upon the language in which the text is generated or text is collected, right, you may have various applications, right? So generation of the speech from the text to speech. So normally the whole text data as well as the speech data all together go hand in hand under a category called natural language processing. Okay, so over there you have applications related to the language. Most of the time this is what the basic application of the text data is in. I'll call it as language tasks, right? And the one challenge here is text should be converted into numbers. Okay, so I think we have discussed this once somewhere, right? But I'll ask that question again, and even if you don't understand this, no problem. We have a complete module called NLP. There we are going to discuss in pretty much detail, but it's going to come once we touch the deep learning part. All right, not before that. So anybody who remembers why the text, whatever text we have, right? It's a necessity that you will convert that into numbers. You want to keep the text as is.
Sir, whenever we have some categorical value, we need to convert them in numerical values.
Okay, so that is in terms of your why, right? Why you are
Yes,
saying
sir.
that. If I
Yes,
say a particular comment is positive, you may say that is plus 1. If I say a comment is negative, you may make it as -1. Correct? So that's what
Yes,
you are
sir.
saying. Perfect.
Yes,
But
sir.
here my question is that if I say hello, how are you? In order to process this, I have to convert this hello, how are you into numbers. That's what is this point.
Yes,
Okay?
sir.
Not just a Y column, the complete data set what you have. Right? So, for example, previously when somebody asked about the tabular format of the text data, I gave an example like if your application is to classify a review of a product into positive or negative, you will put the reviews in right in one column. So column number in a column number 1, first, second, third, 4 are my 4 different comments I got for a product. Okay, and the next column will be my Y column where I say, okay, this comment is positive, next comment is negative, next comment is positive, next comment negative, and so on. So this positive, negative, yes, as you told, will convert. That's a one hot input, right? It will get converted into ones or minus ones or ones or zeros, whatever. But
So we have to convert each character in binary number.
Each character into binary, but again, we'll discuss this in pretty much detail. So yes, there are pretty various types of conversions possible. Maybe what you told is also going to work. We'll discuss that later. I will not answer whether that is right or wrong right now. So the data needs to be converted into the numerical form, right? Why is my question? It is just because the machines will handle only numbers. Machines cannot handle the text data. You never see that machines handling ABC or something. Though it is right written ABC, yes, as you told, it has to be converted into any other format so that machines can understand. Correct? So that is what is one of the challenge that everybody is going to face whenever you try to deal with this. So these are the major classes of the data. Plus, again, I have the speech coming up, but anyway, I'll not include speech here because speech is actually a something like a random data. So far, whatever we have collected may not fall under that case. So again, it comes under the signal processing. So we need to look at the signal processing aspect, which I think every one of you might not have come across. So I don't want to touch or include that over here. So, but these, whatever we have written here, the 4 different types of data, the tabular one, the time series, followed by image and the text are most common for all of us. Okay, so I just wanted you to recall this because yes, right, the overall big picture here is that you can convert them into the tabular form, right? In one or the other way, you can put them into a tabular format, right? Or whenever you collect some data set in the real time, it may be present in any format. Okay, but you always have a facility so that you can store it in a tab. You can make a table and you can store it over there, so that whenever you want to read that data or use that data next time, some other time, you can directly bring it into the memory of your computer in a very neat fashion, like a table, and you can use it. Okay, so that's the use of tabular data. Okay, so now I also want you to recall one more thing. Okay, let me make you to recall that. So I have my features X. This diagram I think you are seeing for at least you have seen at least 2 or 3 times. by now. Okay, so there is a machine learning model. The model has certain parameters theta, so using which it's going to calculate, make a prediction of the y cap. Okay, so X are the features again related to the table. First, if you accept the last column, everything in your table you can give as input. Okay, that is X. So using that, machine has to predict some parameters, and using those all X values, X1, X2, X3, X4, dot, 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 right, up to, if there are M columns, X1, X2, X3, up to Xm, it has to predict the possible Y. Okay, so Y cap is a prediction, Y is the actual value. Then using that Y cap minus Y, the magnitude of Y cap minus Y, you did define what is called as an error, and use that error, right, in some way to train the machine, update, etc. Many things will happen. So that's what we have seen here. So now whatever we discussed here, right, is actually, you can have a table, correct? It's a tabular data, fine. Then you can even pass the image, okay, and you can even pass the text, let's say, or even the time series, fine, right? So on the other side, what are the various possibilities you have? You may want to do a regression, correct, depending upon whatever is your data set. Then you may go for a classification, and as already you have told, depending upon whether it is a continuous, this is for the continuous data set, this is for the right discrete, or the, I just write cat. Okay, that's a categorical data set. If your data set, depending upon what type of data set that you are using, you have these two objectives possible. Okay, now, okay, let's look at the hierarchy in which we were discussing all the concepts under machine learning so far. We started with some, let us say, initially, or let's take a different perspective. Let's not say that what we have done. Let's say we are doing a marketing, fine. So the fundamental idea is that you own a business now, and a particular customer comes to you saying that this is my problem, I want to do a classification of so and so. Maybe, right, you support the what do you call, automated driving system, right? ADAS, the related manufacturer, let's say. So, right, you develop the systems, and you send it, or you sell it to maybe the major automotive giants like BMW, Audi, right, Benz, etc. So let's say somebody comes to you saying that I face this problem, and right, whatever system I have right now inside I am able to detect the pedestrians with the very less percentage, maybe something like okay, let's say initial, this is the initial stage. So they say that I just have 30% accuracy, so it's very poor. It's not able to what do you call, detect the pedestrians who are crossing the road properly. So I'm not able to go ahead with my ongoing project, right? So of developing the complete automatic car, right? So yes, you will say, how do you improve your business, how do you sell your technique, right? So what do you say? Okay, so we have so and so products. One of the product actually implements a very simple machine learning algorithm, maybe maybe you can go for logistic regression, or you can even go for any other, whatever we have studied so far. Okay, like simple the first one I said was a logistic regression. Maybe then you say that I know SVM, we can build you this using SVM, and all. Maybe this is just a number, but actually this will be larger. You will simply say that it's a 50%. Okay, I get a 50%. I can make it 50% accuracy to this. For this, this is the cost, right? Then if you want to further improve, you will definitely say that I know ensemble learning. Like I can build the decision trees, and I can I can grow different decision trees, and I can build the random forest as one of the example, right? That can be one of the ensemble learning. And I know the other ensemble techniques, voting classifier, bragging classifier, etc. If you go for that, maybe that's 70%. I can bring up to 70%, and this is the cost of that. Okay, but what if you want to go further, right? So maybe, right, then for the data sets such as maybe the tabular data set, this is going to work most of the time. So what if I want to go for 90%, right? So then you have the very best suitable method, that is what is called as the boosting. All right, so it's actually continuation of the ensemble whatever we have seen earlier, right? And right, something more than that. All right, so maybe that's how the various levels in which we are studying, that is actually a continuity. So I'm trying to relate, right, how they are, right, at what level, why we studied the logistic regressions first, why we then went to the next, that is decision trees, why we went for the next one ensemble, and inside the ensemble we studied various parts. Now we are going for the next level, that's the boosting. So just to make sure that you understand this flow, right, I just gave this again example. Okay, so but before going to the boosting, I have another very important example that is coming into picture. So let us say, okay, let me try to draw something. Okay, anyway, say that this is a photo, all right, and let's say there is a tree. Fine, there is a tree over here. Just think that this is a tree, though this is not looking like a tree. And let's say there is someone who is riding a bicycle. Okay, maybe. All right, so this is how it looks like. There's a person sitting over here. Just think that he's somehow riding this. Okay, now again, so I'm coming back to the one particular class of type of data set, that's the image data, right? If the image processing or the vision task is supposed to be performed on this, there are various categories of problems coming into picture. Okay, I'm trying to define that now, and how and why the boosting is applicable over here, right? We'll see. Okay, and okay, so this is the scenario. Maybe there is another, his friend is also there. So there are two bicycles, two people riding it, and maybe you have some other objects also possible in this particular scene. Okay, so in this scenario, there is one category of the problem definition which says that it's a single label multi-class. Again, it's a classification task. So maybe the possible question could be, it's a single label, in the sense you have to label this whole image into one class. Okay, so that is single label. Why it is, though I said you need to classify it into one class, why this, the name says multi-class? There are many classes possible. Like I show an image to the trained model and I ask that whether this image is cat or dog. So you just have to identify that whether it is cat or dog. So cat is a class, dog is another class. So you see multi-classes are there, but only single label comes at a time. So you will name it as only dog or cat. So if there are 4 classes, dog, cat, table, chair, out of my possible test data set. Okay, in which case again you see that only single label will come as an answer. Answer is only one of them. Either it can say it's a table, it's a dog, anything. But you see, there are multi-classes possible. So in this case, right, so maybe something like your answers could be, it's a biking. It may say you are running. It may also say somebody is swimming. Right? So you see that it's a single label given at a time. The whole image, irrespective of what is there, there is a road. Okay, sorry, it came out of the image. Sorry, there is a road. It doesn't, you don't have to worry about what type of road it is, how many trees are there. You don't have to. Okay, so this is one category, one very specific type of problem that we are going to face. And the next one, right? So the next category, considering the same image, I will say that this is multi-label Okay, I don't have to worry about the number of classes here because there will be multiple labels coming into picture. Okay, multi-label classification. Okay, so this is the next category wherein for a same given image, right, your output could be you are expecting the machine to tell the following, right? You may say that, okay, there is a bike because bike is also detected. Okay, then there is a person, there is tree. Okay, there could be some other classes which you say that they are not present, but in another set of your training data, you may have the following, something like a boat. You may also have cars in some of them. You may have houses, etc. So your classifier will say that, okay, in this given image, you have a bike, you have person, you have tree, you don't have boat, you don't, and then whatever is not there, it will not tell anything. Okay, so for an image, it creates the following labels that, okay, I found these objects inside the image. Okay, so this is the next type of problem, right, that we face. I'll relate this to the main problem at a later stage. So let's first define the problem first. Then the another very important type of problem that we face, it's actually called as the image segmentation. It's image segmentation. Can anybody try to tell what it is, what you are actually going to do? If I say there is an image segmentation task, so segmenting the cancerous cells from the some image, CT scan or a PET scan or anything, identifying the virus locations from the chest X-ray, right? So it's a segmentation task. What is it? What you are doing here? Can you try to tell me what is the actual task over? Is it something like what we have done already, or are you going to do something new over there? What do you think? Just guess, doesn't matter. Okay, so Swapnil says you are going to crop it. Okay, how you are going to crop? On what basis? How do you go about it?
So what was the question? I didn't get it.
Yeah,
Actually,
question is
network
this. So the next type of problem that we face is image segmentation. So my question was, what do you think? What you are going to do here in a segmentation?
we make a segment of every label.
How do you do that?
Like,
on what basis? You're right, but needs to be, you need to complete the sentence. I do this by doing so and so. So yes, we have answer coming up. Ruchi says you will try to slice the based on some pixel, right? Maybe mapping is one option. We have varieties of options, but yes, I like that word pixels coming into picture because, right, what you are trying to do here, unlike the previous two cases, in this segmentation, every pixel, you are pixel by pixel, you are going to do some operation. Okay, so what you do, you will say that, okay, first pixel, is it human? Is this pixel belongs to a human? Because in my classes I see there is a person over there, because in my previous thing you see bike, person, tree. So every pixel you will check, okay, this pixel, is it for bike, right? Is it for person? Is it for a tree? Right? Based on some category, you have to do that. But pixel wise, you do the operation is what is very important. You may not do the pixel wise operation in any of the previous cases. Okay, so pixel wise, you do a check. Then you make a group of pixels which say that yes, this belongs to a person. Okay, give a color to it. So segmentation results are not actually the small pieces of your images. Image itself will be, right, wherever the human, if you see a person, something maybe just like, let's say in this image there is only one person. Okay, so when the person is said that, okay, whenever you are segmenting this, the complete image will get a color. Wherever the person lies, you will get a color around that, because all such pixels are identified. So whatever you see red here, right, inside that you will get some color. Okay, maybe I'll try to make everything as a red. So you see that the black was my input, the whole thing was my input image. It will make all the pixels belonging to a person, it will put a color to. Okay, maybe that's option in the sense you may have to write a code for that, but still you see that the segmentation results is something like that, depending upon the pixels and the relationship between pixels. Again, I'm bringing the image processing concept over here, but if you feel uncomfortable, don't worry about that. It's going to come at a later stage when we touch the computer vision and after the deep learning also. Okay, so you will try to relate the pixels, whichever pixels said that yes, this belongs to man, you give a color to that. So once the complete image is processed, you will get a same color around the human being. So at the same time, if he's riding a bicycle, maybe that by you will write a code saying that okay, if he's riding a bicycle, give a color to the bicycle. Okay, so what it does, it will give another color to the bicycle, because every pixel that belongs to the bicycle, when you connect all of them with the same color, it makes a structure too. So it will say that okay, so this part, right, of the image, whatever you see here, right, it's actually belonging to, right, another this thing, it's actually a bicycle. So you are actually trying to segment this. All right, so I hope you are able to understand the way of addressing these problems. All right, then comes the the major application. Can you guess? It's called as the object detection. What do you think? What you're going to do here?
Just a question.
Yes, please.
That in image segmentation, if
Hmm.
we can you scroll up like
Yeah,
little bit?
sure, no problem. This one?
So in the picture, so the red one is a person and the blue one is the bike, right?
Yeah,
So
correct.
overlapping can happen in this.
No problem. It can happen.
It can happen, right?
Yes.
Okay.
All right.
Okay.
Sure. Right. So coming to the next question that I have, it's the next category of the problems that we face under this is the object detection. So what do you think? What is object detection?
Maybe it's the same as image segmentation. Like what are the various objects in the picture or
Okay. So the approach is slightly different. You will try to identify the objects. Okay. You will also try to name them. There will be a labeling coming into picture. But in addition to that, on a real time scenario, right? You might have seen this in various demonstration or various videos or something, right? The object detection problem actually has another step to that, another requirement to that. So the requirement is something like this. Let me draw. Okay, so if at all I say that okay, let me write like this. So there is a tree. Fine, in the image there is a tree. Okay, this is a tree, and there is a person. Okay, and the person is actually riding a bicycle. And again, I'll keep the same problem. All right, so this is how it is. Okay, so this is 1 2. All right, fine. And maybe what I do, I'll also bring in another object. Let's say there is a street light. Very easy. Okay, so there is a street light present. In this case, if you are trying to solve an object detection problem, so you understand what is an object: human, cycle, tree, and the street light, etc. Those are the objects that are present. So the requirement is that, right, you will not only find out, there may be a segmentation task, because this problem can be solved using the segmentation also, but there are various other what you call robust and state-of-art techniques that are available, because of having the GPUs and computational power that is available for us, right? Instead of going for any other method, we can go for those advanced methods like YOLO, FCOS, etc. They are the very advanced techniques that we can understand after looking at the deep learning only. Okay, but anyway, so before that, so what is the task here? The task here is, right, to not only to identify where are the objects, you need to put a bounding box around the object. You need to generate those bounding boxes. That is, if you have a human here, so you will generate a bounding box around the human, saying that, okay, this is where the human is. Okay, plus if for, let's assume, so this is a bicycle, you can have overlapping bounding boxes, no problem. Okay, and let me say, all right, so this is a okay, let me slightly bring this closer. Oh, sorry, my bounding boxes were overlapping, I don't want that. Okay, let me say this is where the street light is. Okay, and one more, I'll bring the same red color, and you will say that, okay, this is where is the tree. Fine. So basically, right, in order to plot these bounding boxes, you need what? You need what? You need maybe you will say that 4 corners, right? I need x1, y. If you go for corners, I need 8 points to be generated: x1, y1, x2, y2, x3, y3, x4, y4. Okay, that's the right answer. You can say that the machine has to. If I'm teaching the machine how to find out these bounding boxes, I need to teach machine that how to predict those, right? Those points. Okay, how to class again? Do you think it is a classification problem or it's a different problem? What do you think? Like
It's a classification problem because we are, giving all the things a different class, right?
okay, so you are classifying. So if you are saying that you are simply identifying that there is a human being, then that is what, that will be a classification problem. But in addition to that, I'm saying that I need a bounding box around it, correct? So what do you think? How the mesh, how can you teach the machine to get these bounding boxes around each of the object? Because what you are guessing over there, what you're trying to find, because the length can vary, width can vary. So what do you think? So definitely there is a label coming up. So as you told, yes, your answer is right. I'm not saying that is wrong. So what you said is right. So it will say that, okay, person, it will say that street light. All right. It will also say that there is a tree. It will say that this is a bicycle. But in order to go for that bounding boxes, what do you need? Either the 4 corners. 4 corners means 8 points, correct? 8 points, x1, y1. For every point you need x1, y1, x2, y2, right? The position of the pixels, the corners of 4 corners are what we are expecting. Easy. Either that's one possibility, but I'll tell you another method that is more easier. You don't need 8 points, you need only 4 points. Okay, 2, still you can get the bounding box, right? But my question is not that what points you calculate is not my question. My question is, what is your procedure? Are you doing the classification? Classification is something like, okay, this is a human being, you identify that there is a person in it, that is a classification. But this bounding box, right? If you are seeing my video, I am expecting on your system, whenever I move my hand, right, there should be a bounding box around the hand saying that, okay, this is the hand, right? So hand identification, that identifying that there is a hand in the video that is coming on your screen is classification. But as soon as I remove my hand, right, something changes. Okay, that change is what you are trying to identify, and you are trying to make changes in your the bounding box, so that bounding box actually moves as you do something. So what is that is my question. Are you doing some sort of regression? I'll make my question more clear. Are you generating a series of numbers which are continuous? Because these corners are actually moving, right? So this problem, now if you are able to recall what we actually have done earlier, right, you are actually trying to do a classification plus regression, both all together. So that actually solves this kind of problem. So object detection needs classification plus a regression. Okay, so just as of now, this much is enough, right? I don't want to go in much detail about it, but if you are able to catch what I said, more than enough. Okay, all right.
Yeah.
Now, yeah. Please go ahead.
You said it's a object detection is a regression plus classification, right?
Yeah.
And you give the example, the hand is moving, so it is detecting that this is a hand. What if the hand is
Still you need to generate a number, right? So in this case, in this image, what you are seeing here, right? Regression has to be performed because you are supposed to find out 4 different objects. You need to find a box around 4 different objects. You are still generating a series of numbers, right?
Okay.
Okay. So if you have only one object, you don't have to do that. But definitely our object detection problem basically has n number of objects to be detected. Take the autonomous driving vehicle. It has to detect the signboards. It has to detect what color of light of the street light. Is there a human passing, or is it a car which is moving front? Is that car coming towards you, moving away from you? Do you have to apply brakes, etc.? Will be decided based on that, right? So you see many objects to be detected. Correct. So object detection actually requires many things, out of which these two are very important. So various classes of problems are what we are introducing over here. Okay. So to make it very simple, right? Again, we have in order to solve these kind of problems, right? We have two very famous techniques that are solution. We have we can apply 2 different solutions over here, 2 major types. Again, even the machine learning, starting from very basic techniques, you can apply. So okay, this is how I put it. So one of the solution is going to come when we reach the deep learning. That is the ultimate technique. That is called as convolutional neural network. You might have heard the word, right? That's going to come. That's going to come after we finish all the ML techniques and we touch the neural networks, and then we go to the deep learning. You will see that. That is the ultimate. Okay. So with lesser number of computations and very efficiently, right? Those CNNs can be used to detect the object, and you can even bring the bounding box around that very easily. Okay, that's one thing. Anyway, we are not up to that level as of now, so we'll skip that. We will not touch that at all. We'll not discuss anything. So the next option is that, so instead of applying what you call the basic techniques which we have studied so far, can we try to convert this image data into a tabular form and apply the ones which are very famous for tabular data, like the boosting. Okay, boosting is very as per our hierarchy which we discussed, right? Boosting is at the top. Though we have not studied the boosting, I'm trying to make the scenario so that you understand what is the necessity of the boosting. Okay, so you see here, how do I convert this particular image into, right, tabular data is my question. Anybody can you think of a way? Because as of now, this is a color image. So every point has 3 values, like pixel number 1 has R1, G1, B1. Okay. Next I move to the next pixel. That pixel also actually have three values, R2, G2, B2, like that. So what if I try to make them as my columns? R is a column, G is a column, B is a column, and whether that pixel is a tree or not a tree, person, not a person, street light, not a street light, like that. Can I try to convert that into a table? Will it make a table is my first question. Will it work or not? We have to see. Okay, but if I make it into a tabular data, then I know that for tabular data, the very famous one, what we can handle right now is the boosting. Okay, so we can do that. So the answer is yes, this works. Okay, so before the convolutional networks came into picture, right? So people were not having that much of computational power in terms of GPU or TPU. There was no library supporting them, etc. So people used to do this. Okay, this is a working scheme. Okay, so let me try to write what we discussed in the last 10-15 minutes, because I didn't write any point. I was just telling many things over here. Let me try to write it quickly so that when you get this material, you read and you understand. Okay, so if at all my idea is for image classification, right? So normally I can have a single label, right? You in a single label, you may say that it's a binary cat or dog category. Then you can have a multi-class, right? Cat, dog, chair, table. All right, that's a multi-class. And in addition, in other than the single label, you can even go for a multi-label. On a same image, you will say that there is a dog here, there is a cat here, there is also a man standing, there is street light. Okay, so that's a multi-label form. And then the next one which we discussed was a segmentation. So if that's my target, as the word pixels were brought first over there, so I will start with the same point. Okay, this is pixel wise identity of classes. Okay, then maybe I think we directly went to the object detection. What do you do here, right? Main point is bounding boxes. Okay, very important. Most of the computer vision tasks that are either under progress or very recently developed, okay, they are basically working on the object detection. All right, so those who are really interested to go into this domain, right, you can think, you can get some papers out of it, whatever very recently published, you can try to read and you can try to understand as we proceed with the computer vision. Okay, so right, from a camera you want to detect the faces out of it, right? From a camera you want to say that he's smiling or identifying the various expressions out of it, right? The mobile phones capturing a picture whenever you do like this, right? So that's actually right falling under this kind of problems. So I said that bounding boxes are required. So normally what happens, you will go with 4 points. You teach the machine to do a regression task in after the classification. First it will identify that okay, there is a human being in the image. So then you teach you to do a regression of what, right? Regression of the center pixel. Center pixel in the sense, if there is a man standing here, somewhere here you will find out a center pixel. Okay, somewhere here maybe. Okay, so that is x comma y. You have right 2 points over, because I said I don't want to make it more complicated by teaching the machine to predict 8 numbers, because if you go for 4 corners, each corner has 2 coordinates, x1 y1, x2 y2, x3 y3, x4 y4. So that's sum is 8. I want to reduce the task. What do? Go for a central pixel, because let me say let me draw the bounding box. So let me say this is a bounding box which I want to generate. Right, there is a central pixel. From the central pixel you need only 2 more things. One is what is the height. Okay, take this much height. So height is a number, right? From the central pixel, half of the weight is enough. If the total height is say 20, you just have to go up 10, below 10. So just generate a number 10. Okay, so that's the third number. And similar way, you need to tell what is the width. So again, the width is actually expected to be equal. In this diagram, you may see that it's not equal, but actually it is equal. So if the width is 20, so 10 on one side, 10 on the other side. That's why it is the central pixel. So central pixel needs 2 values, and the height, 1 more number, width, 1 more number. So just then teach machine to generate this, you get a bounding box. All right. So that's what is required. All right, so again, I'll touch another problem, right? That is also very famous, and we will face it. We will be addressing this problem. That's why even it takes some time, no problem. I'm ready to spend that much time over here. Okay, so the next category after image is one category where yes, you will try to convert that into tables and you handle it right in something. And the second one is this kind of data set. It is NLP, natural language processing. Yes, please go ahead.
Sir, that above example, we gonna do that, right? Like making bounding boxes.
Yeah, in the object detection. Okay.
Okay. In NLP, but right?
No, not in NLP. NLP is natural language processing. It's a text. Okay, that is image.
Okay. Okay.
This is image data. What you see there is an image data. This is a NLP is a text data. Okay, so I moved to the next category. Right. So basically in NLP, right, the goal is nowadays, again, I'm saying what is happening right now in NLP, because NLP is a very huge task. NLP and its application started maybe 10 years ago. So where originally the objective was just to identify what is the language he is talking about. What is the language somebody is typing? Identifying language was the oldest task. Now it is no more valid, because for most of the languages, there are models very well built. And you can see that even when you speak to the OK Google or Siri or anything, right? Alexa, in your local language, for some extent it is able to identify, which means there is a language model that actually has been built by so and so. Okay, but nowadays the research is tending towards getting the insight of what you are speaking, not just which language you speak, right? Are you happy when you say something, or you are not happy? Like, what is your mood, right? Maybe guessing that, because people want to build the business based on that nowadays. So it's not just identifying which language you speak. Okay, so actually that's how it is. Again, a lot of research is already being carried out in most widely spoken languages, right? English, Hindi, and worldwide European languages are actually having a very good support in terms of the research. There are models that exist, but other languages do not have. Other regional languages might not have a lot of support in terms of the research. Yes, those who are interested, yes, that's one field where you will work. You can work. Okay, so basically I divide this into two parts. Again, I'll talk only in terms of the text. I'll not touch the speech. I told you what's the reason. So fine, I'll say the first thing is the text classification. If you look at the research that were those researches which were carried out more than 10 years ago, classification of language was the major task. Even you will find the research papers on that, because people were not having that much resources, or not such supporting libraries or anything like that, which actually helped in identifying the language. So how do you identify each language? You need to do a language modeling, etc. That was the problem earlier. But now you see the problems that we are trying to solve nowadays. Those who are doing the research on the NLP side, they're actually trying to solve the problems based on what is called as a topic modeling. Right? What do you mean by topic modeling? What is the topic of this text is what you are trying to find out. Okay, then in the sense, are you trying to write a technical you are talking, or in the sense, there may be, if you are talking, it will get converted into text first, then this topic begins. Okay, so somebody is typing something and you run your code to identify, is it a technical content, or he is talking about sports, something like that. Okay, so this is the topic modeling. Then we also see the content filtering. So you may build an app that takes the text data from it and you remove all the abusive words. You are filtering it out. Okay, then another very important one is the sentiment. Sentiment analysis. So that's one thing. It's a classification task. Again, there is a regression coming into picture that falls under the text regression. Okay, so this is something like, one of them is very widely used nowadays. You will see that in your browser or when you type mails, right? So that is a sentence completion. Again, there is a language modeling required before this, because it actually has to identify which language you are typing. Okay, only when it understands that, it can suggest, okay, if I say hi, the next language could the next word that I'm going to use should be hello, maybe. Okay, so only if it understands it is English, then it can suggest that. So there is language modeling plus this topic comes into picture. Okay, then the translation. So I give a phrase or a sentence in one language, and I say that I want this to be converted into another language. So how that happens, that's what it is. Okay, then there is another very important that is summarization. Okay, and the boards, right? You define the boards for this purpose. That's a question answering or chat. You can build many things out of it. Okay, so all this is possible, right, by using what is called as a boosting, right? So the machine learning applications can be built using this, but current scenario, nobody will use this. They will go for the advanced techniques like deep learning, right, for this. Okay, so I try to define something over here. Now onwards, we'll try to address one by one. Okay, maybe we may randomly take one of the problem and we'll try to solve when we do a project, right, towards the end. But these are the major issues that we commonly face, or if you are going to do a research, most of the time you will pick one of these topics which we have discussed over here. Okay, so now the boosting begins. Okay, I'll just write the heading once again. This is boosting. So far we were discussing just the basics, the introduction part that is required for this. All right, so now what is the boosting? So this is, right, boosting is, as we know, the one level. If you go below, we have ensemble. Okay, so this has to be, what do you expect? This has to be something more than ensemble, correct? So this is actually called as a sequential ensemble. It's a sequential ensemble method. So try to recall the ensemble method. What is ensemble? I use classifier 1, classifier 2, classifier 3, classifier 4, up to n number of classifiers, right? I train them individually, right? And I give a question like a test data. I'll show a photo and I ask each one of those classifiers saying that whether this is cat or dog. So each one individually, whatever it has learned during the training, it actually looks back, right? Whatever it has learned, according to that knowledge, it will say, okay, this is the answer. It's a cat. Next one may say it is dog. Then the third classifier again, some other answer, like that. It gives an answer. Then, there are several methods available, voting, dragging, etc. So using that, you will get an answer. So if that is the case, it's a voting classifier. Or if you go for the random forest, which is actually a very specific case of the ensemble learning, where you are building the trees as the basic units. So you use the decision tree number 1, tree number 2, up to tree number maybe 1000. So each of the tree will be trained, right, by using the bagging, and randomly you give a subset of your data set for each of the tree, and trees learn. Okay, and you know how it is. But so far, in any of these cases, there was no relationship between the trees or any other classifier. So you can use any classifier, right? Ensemble learning works in the fact that you can build any classifier over there. You can use any classifier. Specifically, if you use only trees, it becomes a random forest. Okay, so in that, in under the hood of this ensemble learning, what we have seen here, right, there was no relationship, in the sense what one tree learns has nothing to do with the next tree. It is what that tree learns. Okay, there are no parameters getting exchanged, or nobody has an idea that how much error my neighboring tree is actually having, etc. You don't have any idea about it. Okay, so nobody was worried about that. So people thought that can we improvise this method by training one tree at a time, not all of them together. Okay, so previously you were doing it parallel, you can think like that. Now what you do, try to do, if you are having a tree, train a first tree. Okay, train and test. Once you do the testing, you will come to know how much error it has. Okay, now what if you will make sure that the second tree is going to learn from the errors made by the first tree. Okay, it's a better thing, right? Because you see that, okay, somebody already has done mistake, so normally elders will say, right, learn from others mistake, why you also do the same mistake again and again? This is a common thing we hear from elders always, correct? So it's a similar scenario, right? So what if this works? All right, so I'll write the general idea. Okay, so the researchers thought that you train the predictors sequentially. So that means you will train one by one. First tree, then the second tree, then the third tree. So from the learnings of the previous tree, you will decide what to learn for the second tree. From that, you learn what should be taught for the third tree, and so on. Okay. So train the predictors in the sense those classifiers sequentially, so that each successive predictor corrects the errors of its right. So its previous learner, whatever mistakes that actually happened over there, you are trying to correct them now. Okay, that doesn't mean that you cannot make a new error. So that is impossible. You cannot put a restriction over there. You can make some mistake, but ultimate goal is to make sure that whoever has done the previous mistake, you try to correct it. So I may make a new mistake while correcting the other mistake. My next whoever is going to learn next will try to correct. Okay, so that's the complete goal of this. This was the idea initially. Okay.
So basically, if there are three methods like logistic regression, SVM, and KNN. Okay, so first it will do the logistic regression. If there is an error, the KNN will automatically resolve it according to this, right?
Yeah, that's what is this idea.
So matlab the next algorithm or classification depends on the previous one.
So we are trying to make sure that there is a sequential learning, not all together. This is the first idea.
Okay.
Second thing is that you will try to make sure that when somebody learns and makes a mistake, you will try to pass that mistake somehow to the next whoever is going to learn. And you say that, okay, these were the mistake, you don't do that mistake. That's all.
Okay.
Okay. All right. So let's look at this sequential learning once. Sequential learning system is what I call. Now, so what happens? Let's start with the first learner. What happens with the first learner? There is no restriction. You are not going to give anything, but you give the complete data set, right? So this is my data set. Okay, I'm going to give this data set to learner number 1. What happens over there, right? That learner will use the complete data set that you give, and right, because of that learning, whether it is correct or not, there will be some error, right? First learner, right, learns from the data set and may result in some error or wrong predictions. This is obvious because we have, right, whenever the training data set is too huge, right, there will be mistakes. Okay, you will never be able to reach 100% if your actual data set is too huge. So that's obvious, right? Now what happens after this, right? There comes the second learner. So what is expected, right? Whatever second learner learns, third learner will use the same concept and learn something more out of it. Okay, so second learner, I can say, tries to learn from the wrong prediction. Okay, learn from the wrong predictions. Okay, it may also result in some wrong prediction. I'm not saying that you will correct everything, because when I say, okay, this is a wrong answer and don't do this, right? When I ask the same question again, some of my students may say the same answer again. There can't be a mistake. Okay, so I cannot say that whenever I say this is the wrong answer, don't do this, I cannot expect everybody to learn. So there will be some mistakes. Okay, so learn from the wrong predictions and makes few more wrong predictions, right? And this process repeats, right? So whatever the second learner has made some mistake, right? From that we make the third learner to learn something. There you may correct these errors that made by the second learner, but that may result in something new. Okay, so like that it progresses all the way through. Okay, so
sir, the data set will be given to just the first learner or the second learner also?
everybody. Data set has to be given
Everybody.
to everyone, right?
Okay.
Okay, the complete data set will be given to everyone, but you will try to make sure that, okay, these are the mistakes made by your previous learner. You will highlight that somewhere. Okay, so from there you make the machine to learn more from the errors rather than your actual data. This is what was the idea. Original idea was that. Okay, later on there will be some modifications anyway, so we'll not touch the ultimate levels of boosting algorithms. So we'll discuss the basics in this session. Okay, so right now that's how it works. Okay, so now basically, out of the various types of boosting algorithms that exist under the hood of the boosting, right, we have very famous two of them, right? One is called as the adaptive, right? This is in short you call ADABOOST, right? So this is applicable if you are trying to solve a classification problem. Okay, similarly there is another one that is actually called as gradient boosting. Okay, this is called as XG boost. If you are trying to solve a regression problem, right, the particular method that we are going to use will be called as the XG boost. Okay, that's a regression problem. All right, let's look at the details. What exactly is going to happen under the boosting algorithm compared to the ensemble. All right. So let's do. Okay, let's take up an example. Right. So what I do, let's say I have a few of the shapes. So let me draw some shapes over here. Okay. So, or even colors will work, but coloring may not be an option here because I don't have many colors in my color palette. All right. So let me go with the shapes. All right. So triangle. Okay. Triangle, square. This is my data set. Okay. So I can have rectangle, triangle. All right. Another triangle, rectangle, rectangle. Okay, this is my data set. Let me assume. Okay, and this is what I call as the original data. This data, what happens? I'm going to pass this to a classifier. That's classifier number 1. All right. So this classifier is going to give you a result. Okay. Let's say that result has, again, let's assume that this is a binary classifier. Yes or no type. So what happens? Let me write the 2 classes that this machine generates. This is one of the class, and let me say this is the other class. Okay, there are 2 classes generated. Let me count how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15. We have 15 data points, out of which let me say, okay, it actually classifies in the following way. Let me say how many triangles? 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4 triangles, and let me say 1 rectangle. Okay, there is a mistake. Mistakes are possible. Okay, it says that this is one class. I'm going to call this is a class, say true class. It says it's a true +1, and there is a false class. Maybe all the remaining, right? If you see there are 2 rectangles, and all the triangles I think I removed 1, 2, 3, 4. Okay, one triangle is still there out of that class, and remaining are circles, right? 1, 2, 3, 4, 5, 6, 7, out of which one, okay, all 7. 1, 2, 3, 4, 5, 6, 7. So there are how many? 7, 10, 11, 12, 13, 14, 15. Okay. So you see, this is how the machine actually the first learner, right, classifies. Okay, as a result, it actually may have done a mistake, saying that okay, though my classes are supposed to be separating out of all the triangles from the rest, right, it actually has been some mistake. Okay, one of the rectangle is actually coming under the true class, and one of the actual data, which is triangle, actually has gone to the false category. There are mistakes that are happening. Okay, fine. This is possible. Again, if you refer what you call the various textbooks or various resources, there may be another view of this problem. Okay, so I'll just try to give a quick view of that. So what if this is all about identifying the various what you call shapes, right? So various shapes are given. Machine has to say that which shape it is. Like triangle, it has to, when I give a triangle shape, it has to say it is a triangle. When I give a rectangle, it has to say a rectangle. So the same problem, this classification, you can say that true actually is a category where machine actually has identified. In the sense, 4 of the triangles and 1 of the rectangle, machine has identified. It's correct. Okay. The false category is something where machine made a mistake, right? In such case, you can see that this is a right answer, this is a wrong answer given by the machine. You may separate them off so that you can see, okay, these are the errors made by the machine. You can say that the X, wherever I have written X class, right, X category, that is actually the machine, wherever the machine made mistake. Because, for example, right, from that F class or the X category, I gave a circle, but machine said that this is a rectangle. So there is a mistake. That's why all the circles it made a mistake. Possible. Okay, so you can analyze in any of the way. Don't get confused. Fine. So what happens, right? Initially.
So, sir, in this data set, we want to classify triangles, right? Only triangles. That's why the true is 4 triangles and 1 rectangle, and the false is the rest of them.
Yeah.
Okay.
Right. So as I told, there are two versions, right? You can take anyone which you feel right. Okay. One is that what you said. One is the other one which I said just before. Okay. All right. Now, what basically is going to happen here is, okay, I'll leave this space. I have to draw something more here. The next thing I'll write below this. So what is the standard, right? I'm actually starting with the adaptive boosting, the classification problems. All right. So in ADABOOST, so I'll write here. Okay, so normally this is the standard procedure. Okay, the standard procedure is that you will start. This is the starting point, right? Now I define the problem, and again, ADABOOST actually normally ADABOOST actually implements the decision trees inside. Okay, so that's another convention. That's all. There is no rule saying that you have to use the same thing. It is easy to train the decision trees, and under the decision tree you see many advantages compared to all other techniques. So people prefer implementing the decision trees. Okay, so again, it's a convention. Again, if you refer various textbooks or various standard references from over the internet, you will see that yes, people use decision trees under this. Okay, but yes, it doesn't mean that you cannot use any other classifier. Okay. Right. So this is how it begins. So you start with all samples having same weight. So you are supposed to provide a weight for each one. Okay, why the weight is required? So far we never assumed any weight in any of the previous technique. Now every data sample is expected to have a weight for. Okay, why it is required, I'll come to that later. Okay, but yes, this is the first step. Right, so you need to assign equal weights. If I have 1000 data points, you can give 1 by 1000. So 1 by 1000 for the first data, 1 by 1000 for the second data, 1 by 1000 for the third data, and so on. So each of your data set, data point, each point in your data set will get a equal weightage. Start with that. Later on you will change it depending upon some condition. What is that condition? And how the weights are going to be updated, how the weights are going to be changed, etc. We are going to see that. But before that, let's go for a break. And when we come back, we'll continue this ADABOOST technique. We were discussing about the steps that will be followed while implementing the ADABOOST, which stands for Adaptive Boosting Algorithm. So, as per the first step that we have seen already, we will start the algorithm by assigning a weight, and we'll keep that weight equal for every data sample. So why this kind of weighting is required? It is because for whichever data point the first learner makes an error, we will try to give extra weightage for that, so that the next learner may understand that, okay, whoever has more, whichever data point gets more weightage, it has to learn that particular data point with carefully. Okay, it has to learn carefully about that. So this is the idea, right? Otherwise we don't have any other method to justify that, okay, this particular data point, there is a mistake by the previous learner. We don't have any other method to convey that information to the next one. So we'll try to keep a weightage for that. Okay, so this is a weight. let me see what I written. Okay, start with the all samples having the same weight. Okay, so that's a point number one. Then point number two is we will train a base classifier. What is a base classifier? It's a first one. Okay, we start with one of the classifier. Here we'll write in general, but as I told, application wise, people prefer implementing the decision tree. Okay, fine. So implement any base classifier by start with the training of that and make predictions. Make the predictions on okay, we know that. I don't have to write it. So you make it to get some predictions done and see that okay, which of them are correct and which of them are wrong. So whenever you have a wrong prediction, right, you can definitely find error. So I'll denote the error as RK. Okay, R suffix K. So R is the error. K is a counter which tells that which particular classifier you are talking about. First classifier R1, second classifier R2, okay, third classifier R3, and so on. All right. Once that is done, then the fourth step is that we will set a specific value for the weight that is equal to predictor weight. Predictor weight denoted by alpha k. Okay, this is specifically calculated as eta times log. It's actually natural log of 1 minus rk, that is the error calculated in the previous step, divided by rk. Right? What is the significance of this equation? I'll come back to that. But first, let me write down all the steps. Okay, there are I think 2 or 3 more steps left over here. Okay, that's a step number 4. You calculate a predictor weight that is denoted by alpha k. Now we need to update. That is a step number. In step number 5, we'll try to update the weights of what is called as the misclassified data sample. Corresponding to that data sample, whatever was the initial weight, you change it now. Okay, so that that data points can be given more weightage in whenever they are passed on to the next learner. Okay, so that's step number 5, update the weights of misclassified instances of the data points. All right, then let's move to the 6th point. I will do the training once again of the next learner. So train another classifier, a second classifier with the updated weights. So the same data will go to the second classifier, but now it says that okay, give more weightage to this. Something like whenever maybe when I teach, I say that okay, give weightage to these questions because they are very important. Something like that. Okay, so train a second classifier with the I can say updated weights and ask the second classifier to make a prediction. Okay, and make the predictions over there. Okay, now you will repeat the same steps, so I'll just write one more step maybe. So update the instance weights and continue to the next classifier or next learner, and this procedure repeats. To finally, in order to come to a single conclusion, saying that, okay, let's assume a binary classification problem, right? In a binary classification problem, I just have to teach the machine how to classify a cat or a dog. So the final prediction, because after after this learning process, sequential learning process is completed for each and every classifier or learner that is present over there, what do you expect? So at the end, the final classifier says that, okay, this is the result, right? But right, you may have to use, because this is the ensemble learning technique, you may have to use all the opinions of the previous classifiers as well to get your final result. Okay, so for that reason, so this is the last step, step number 8, that is a final prediction. If you want to make a final prediction, that will be done by the process called as the weighted ensemble. So the final prediction, let me just a second. Okay, let me try to denote that as y cap. So y cap is equal to, right? If there are maybe it's a binary classification, means you have two labels, right? So yes or no type. Or if you have multiple labels, also still the same equation is going to work. So maximum, whatever gets a maximum, that is denoted by arg max, maximum argument of a label. Okay, you have to take a summation of the k value starting from 1 to capital N, because already we have used the k. So k actually holds which particular classifier you are talking about right now. So k equal to 1 for the first, k equal to 2 for the second, and so on. So now we assume, in this case, you can see that we are assuming the capital N number of classifiers have been used by us. Okay, so this is you use that alpha k times the particular predictor. This is a notation of x equal to label. In the sense, I'll tell you what is the meaning of this. So the final predictor says that it belongs to a particular class, say class 1. Right, what happens, you will see how many of the overall classifiers, out of all the classifiers, how many will say that it's the same class. Like final predictor say it's a cat, you'll see how many of the previous classifiers say that yes, your image is a cat. You will find out that. So the predictor k of x, in the sense x is your input data, predictor k equal to 1, k equal to 4, k equal to 8, k equal to 10, like that. So many of the predictors have told that this is equal to cat. So find out all those, right? You find out the alpha, that's a weightage of them, take a summation. First one may have a weightage 1 by 8. The third classifier may have a weightage that is equal to, say, 1 by 16. Some numbers will come. That weight which gets updated, right? So that those weights, every classifier gets a weightage, right? That's what is calculated. If you go back and check, there is a calculation for alpha k. Alpha k is the weightage of that classifier. So take a sum of that. So the cat category gets certain weightage. Sum of all these argmax label, right? Maximum, whichever label gets a maximum of this sum, you declare it as that class. So like if the cat gets the summation highest, then it will be a cat. You can declare that the result belongs to the cat category. So whatever is a test image, it is a cat. Otherwise, if at all the other classifiers which said that, okay, given image is dog, take the sum of the weights of those classifiers. That will be the remaining classifiers which were not used in the cat category, that will be present in the dog category, assuming that it's a binary classification problem. Okay, so what do? You go to that. So find out what are the alpha values of those classifiers which say that this is a dog. Take a sum of those weights. All right. So compare the two weights, right? Sum of those weights. When you after you do this summation, find out argmax, whichever gives you the maximum value for a label, say that is your label. Okay, you can do that. That's how this technique basically works. All right. So these are the steps that we follow. Let me come back to the problem that we were solving, right? This was a demo, right? What happens? There is a point in this discussion, there is a point saying that update the weights. So that is step number 5. Because you have calculated an alpha k, I need to use this alpha k to update the weights. Previously I have some weight, you can denote it. Okay, so now I will show you that. Okay, what happens here? Let me consider the same data set once again. All right, what I mean by the same data set, let me copy that. Okay, drawing them once again is not a suggested way, I guess. Let me try to copy. Okay, and let me paste it. Okay, so this is the same data set. Now, all right. What happens here? So, okay, let me erase this. I don't want this and this. I'll put them over here. So this is one class, this is the other class, where you have the wrong classifications, right? So corresponding to the second one, there are mistakes. They are the mistakes made by the machine, let's say. Now what you do, corresponding to these, the wrong classified data set, right? Data points, I will only for them you will update the weight actually. Okay, so how the weight updation happens, this is what is the case. Let me draw something first. Okay, so this actually is collected, this will come here, and this is what I feed to the next learner. But before that, I will make this change. So there is an alpha calculator, step number 4. I'll show you again. Okay, so look at the steps. Step number 1 is everything has the same weightage. So you start with the same weight. So train a classifier, find out error, use that error to calculate the alpha k value. That is a predictor's weight calculation. Weight calculated because of the errors made by the first classifier. Okay, so that is done. And now I use this.
Excuse me, sir.
Yes, Ruchi, please go ahead.
Sir, in first classifier, where we have mentioned that weight factor.
No, initially all are same. You can see for the first one there is no weight factor. First one's result will be used to calculate the error factor. That is used for the weight updation of the next one.
Okay, sir.
Okay.
Yes, sir.
Initially you don't have. Initially you just have this point. You see, start with all samples having the same weights. That's all. Only same
Okay.
weights are. There is no other weight factor that is used. So initially I don't have. If you want, you can keep it 1. If you want to initialize something, you can keep it 1. Because 1 into something, it's remains same.
Okay, sir.
All right. Okay. So, right, I train a classifier. I calculate in step number 3. I calculate an error. Right. How many errors made by that particular classifier? I use it. Then I go to the next. Step number 4. I calculate alpha k. That is alpha 1. It always starts with the alpha 1. Using this. So step number 5 says update the weights of the misclassified instances. Whatever samples were misclassified, only for them you update. Okay, you increase the weightage of that, because if you have, say, just I had 5 data samples, I initially started with the equal weight 1 by 5, 1 by 5, 1 by 5, 1 by 5. So 5 samples got 1 by 5. But out of them, let us say 2 of them got misclassified by the machine. Now what it says is that 3 of them which were correctly classified, keep them same, don't change. But for the others, you have to change. How do you change? Multiply by this alpha value, which is calculated for that particular for the first classifier. So what happens? I'll just write an equation over here. So this is what I write. This is Wj is equal to the Wj into e to the power exponential of the alpha k. Okay, so this is the equation. The j can be written below also, but if I write it below, if people may take it wrongly as the weight of the the kth classifier or something, because inside that on a later stage we can even bring the neural networks, because each neural network has inside some weight, so should not confuse with that. All right, so that's the reason I'm writing on the top, right? So Wj, but the meaning is clear, right? For whichever this is, if I write the Wj, that's the updated weight of this particular classifier which I am going to consider. All right, so according to this notation, let me make the changes. Okay, so what happens here? Whatever I'm going to color now, they are not updated. So whatever I'm going to color now, they get updated. So wherever you had done some mistakes, right, they get updated. So the weight corresponding to this will be updated. Weight corresponding to, okay, only one thing I should leave. So this gets updated. This gets updated. Okay, and this is updated. See, this is updated. This is updated. This is updated. This is updated. So those points, is it right? 1, 2, 3, 4. Okay, one of the triangle also I should update. Okay, so is it right? No, this also should get updated. Correct. So totally 1, 2, 3, 4, 5. 5 points will not get updated. So you see no color for 5 shapes. So whichever belonging to that tick mark category, they are not updated because they are right. They were correctly classified. So whatever data samples were misclassified, only those you will be multiplying. So their weights are going to be updated. Now what happens? Now you see.
Excuse me, sir.
Yes.
Excuse me, sir. Sir, we can choose any random circle or sphere.
No, in this case, yes, because we don't have a clarity about what data set it is. Right? So actually, right, this is something like I have 4 images of cats and 4 images of dogs. Let us say, right? The third cat image is wrong classified, means you have to do the same thing. Okay, third circle means only third circle.
Third circle.
Okay, so for that image only you have to do this. Okay, but showing that is impossible for this kind of discussion, right? So
yes, sir. Yes. Thank you, sir.
Sure. So you see, right? That's the overall meaning that's here. Now you see, I call this data as slightly different. Though all the data samples which we have here, it's not the original data because it's a weighted data. Because each of the samples have different weights now. Previously same weight, so that was considered as original data. You see here, this was original data. Okay, but now what we are going to use to train the next classifier, and any classifier that is going to come after this will not be the original data. All the data samples that were present in your original data will be used, no doubt in that. But the difference is that they cannot be called as original data because not same weightage, the weightage changes, so you call this as the weighted data set. That's a first difference. All right, then this is given to another classifier, classifier 2. Okay, I pass this data to this. This actually again generates some results. So out of those results, you can have completely different than what was there earlier. Okay, so here again it makes some correct predictions. That's what I'm going to show here, and it's also going to make some mistakes. Okay, so the mistakes again I'm going to put it over here. Right. So this could be now maybe, right, whatever mistakes that have been happening in the previous case, maybe you will try to overcome that. In the sense, you see that it, let us assume it tries to learn how to classify all the circles. Okay, how many circles were correctly classified? No, none of them in the previous case. And 1, 2, 3, 4, 5, 6, 7 of them were misclassified in the previous case. So 1, 2, 3, 4, 5, 6, and let me put a triangle here. Okay, these are correctly classified. Remaining will be definitely now it's wrongly classified. Okay, so what is remaining? I have how many triangles remaining over there? 4 triangles. 1, 2, 3, 4, and 3. 1, 2, 3 possible. Okay, so again, this is what we call as the right class. This is what I call as the wrong class.
And there will be one circle also, right?
Yeah, where is it? One circle here. Okay, all right. Is it right now? Okay, just correct me if there is any mistake. Okay, so we have this kind of representation possible. Now for every case like this, right, this is carried out. Now what do? You will calculate, you will update again error here. So corresponding to this, I had R1, you calculate R2, convert this R1 into the alpha 1 using the appropriate equation, convert the R2 into alpha 2, that's a next equation. Now what happens? Look at what are the mistakes, right? And corresponding to those mistakes, right, you go to the next classifier. And when you go to the next classifier, right, what's going to happen? You know now. Is it same? Yeah, I have them here. Now the coloring will happen only to the mistakes that have been, right, happening in the previous one. So I think one of the triangle I leave, all the other triangles will be colored. Okay, then 1, 2, 3, 4, 5, 6 circles I should leave. Only one circle I should make a color. All right, so I'll make a color to this, and one triangle it's left, remaining everything you color. Okay, so 1, 2, 3, is it right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes, so this is what is going to happen, right? Once again you will make a change here. So W2 is equal to W2 whatever was there earlier into exponential of alpha k. So I'll make a modification. Okay, I'll update this. I'll write it properly so that corresponding term itself is getting updated. You will understand that. So this is W1, or simple W also you can write, or W2 is equal to W1 and to something like that. That notation also should work. Okay, this is alpha 1. Now I have W3 that is equal to the W2 into exp exponential of the alpha 2 which is calculated previously. So this procedure continues. How many classifiers you have defined, right, in the ensemble, you can use it over here. Okay, and every classifier will learn in its own way, right? But since there is a weightage given to the wrongly classified data sets of the previous, for the previous classifier, now you see there is a weighted data that actually passes through the from one particular classifier to the next classifier, so that you can say that the weighted data passes, and this is a sequential learning. You are not making the giving the same data set to every classifier simultaneously. Okay, so that's one more the very basic difference that actually comes between the normal ensemble learning and the boosting algorithms. All right, do we have any doubts so far? Whatever we discussed right from the beginning, let me know if you have any doubt.
So when this will be stopped? Like whenever the third classifier will identify all the rectangles and remain.
No, it's not like that. You will define, I need 100 classifiers, I need 1000 classifiers. All will learn. That's all.
Okay.
All will learn. You define. Okay, because you remember the decision trees. You will say that n number of learners equal to 1000. You will define. Correct. So in the same way, here also you will define. Okay, how many learners you have. So it is not going to adaptively keep changing the number of learners. That is not going to happen. You have to fix it initially. You say that I need 100 learners, I need 1000 learners. all of them will learn, but only the first one will get the actual data. Then the weighted data will keeps flowing from a learner to the next learner. Okay, depending upon the weight it generates. All right. So, what is the significance of this alpha?
Excuse me, sir.
Yes, Ruchi, please go ahead.
Sir, will error R1, R2 will be decreasing at each stage?
Not necessarily. It is a variable quantity. Okay, that's all.
Okay.
We don't have any. We cannot justify anything saying that it keeps on reducing, increasing. There is no fixed way, but it keeps changing. That's all.
Okay, sir.
All right. Now,
So
yeah.
if I choose 100 classifiers,
Yes.
then the number of error may be same or may not be same, right?
Yes. Okay. These values, they are used to update your weights of the next classifier. That's all. They are used only for that purpose. Okay. But I have a question. Okay, let's look at the equation of alpha. Okay, you can see the equation of alpha here. This is alpha is equal to eta into log of 1 minus rk by rk, where rk is an error. Normally this error comes in a fraction, like out of 10 data points, 2 were in error. That means this rk is 1 by 5 and so on. Anyway, normally we say that it is in the percentage. That's for human perception. That has nothing to do with the machine's perception. You will keep it as it is, like 1 by 5 is 1 by 5. You give it as it is. Okay. So now I have a question to you. Say that is about what is the significance of this alpha Q. I use the error to calculate this weight, which is going to be used to updation. It's a weight factor which is used to update the weight of my next classifier, right? Update the weight of data points that are going into the next classifier, right? So it's like I have to update using this alpha K. Now, what is its significance is my question. How can you say that this alpha is going to do what it is supposed to do? Is my question. Meanwhile, I'll define what is that eta. Eta is called as a learning rate, right? You can think that it is the same learning rate which we had actually discussed when we I think it was a first or second class of our machine learning topics, and where we have defined a learning rate under the gradient descent. I guess you can think that it is pretty much similar to that, but it's not exactly the same because there is no gradient descent happening over here. Okay, but it's a learning rate. You can say that what percentage of your other term want to go to the left side. If like 50% means whatever happens to the log of that term, 50% of that will go to this side. If I keep eta is 0.5. If I say 1 into log, complete log will be assigned to the left hand. It's that way. Okay, so normally it's a simply multiplication factor, but technically in the references we can see that this eta is a learning rate, right? Okay, so with that I come back to my question. What do you think? What is the significance of this alpha? How the values of alpha is going to be used in how this value of alpha is going to affect your weight updation? That wj is equal to wj into e to the power alpha k is what I write here. So what do you think? How it is going to affect is my question. Very simple answer, not a very complicated answer. You just have to think what will be the values of this rk, because take eta as 1 for that purpose. To answer my question, take eta as 1 so that there is no eta in the whole picture. Simply there is a log term over there. Alpha is equal to log of something. You just have to analyze what happens to the log values for different values of rk, and you can answer that question. It's a very straightforward answer. Okay, either you type your answer in the chat box or you give an answer orally. Both will work fine for me. Okay, I'll give 2 minutes for everyone to think. Very easy answer. So I expect what do you think?
How the alpha will work? That's the question.
Yeah. What happens to alpha? That depending upon the values of rk is my question, because rk is a fraction, you already know, right? It's a error.
Yes.
So think of what are the possible values of error, right? Maybe in that case, you will be able to answer it in a very easy way. For a given classifier, any classifier, what are the different values of this RK could be?
It will
Sir,
set
as-
the next weighted classifier. It will set the next weighted data set, right?
It is used to multiply. You will multiply this alpha with the, so e to the power this alpha will be multiplied to the previous weights to get the current weight. Okay.
Sir,
Yes.
if as
yes, Anji.
RK will decrease, alpha values will be increasing.
Okay. All right. So
We have to put,
huh,
we have to use more weight.
you have to use a larger weight unit.
Yes.
Okay. Let me check that. What you said, as the error increases, you told, right?
Error decreases.
Error decreases.
Yes,
Okay,
sir.
okay. So let's take the RK. RK value is a small value. As you decrease means I'll take it as 0.3, smaller value, maybe.
Yes, sir.
Right? What happens to the alpha K? Can you tell me? Alpha K should be equal to, eta is 1. 1 into, this is log, natural log of 1 minus 0.3, that is 0.7 divided by 0.3. Okay, you get a value. Okay, 0.7 is larger than 0.3, right? So log of a positive number, right? Whatever you get inside this bracket is a positive. So I just write it's a positive number. Let's see. Okay, now the other, right? Because you said as RK reduces, something happens. Okay, as RK increases, what should happen? Let me make it 0.7, it increased, right? So what happens? What is the alpha K? This is 1 times 1 into log of, it's 1 minus 0.7, so that is 0.3 divided by 0.7. Now what happens to this? It's
Negative.
a smaller number by
Yes, sir.
larger number, which means the value is lesser than 1. So any number lesser than 1 will get a negative
Negative number.
value for alpha.
Yes,
K.
sir.
Okay, so it actually in the first case, right, you have weight is equal to the weight into e to the power a positive number. E to the power positive number, right, is
Okay.
right, maybe it's going to become a positive number, right? At the same time you have a negative number coming in the second case, so that means RK is more error made by your machine, right, says that you are multiplying that weight by a negative number. Okay, so now what is the worst case here? What is the worst case? Can anybody guess? That should not happen in any of the machine learning. What is the error that you don't expect? I say that my machine is making more mistakes by saying RK is
Sir,
0.7.
1.
RK equals to 1.
RK is 1. RK equal to 1 means it has not learned anything.
Yes, sir.
Okay.
Yes.
So your alpha value, what happens to your alpha value? In such case, can you calculate 1 minus 1 divided by 1?
It will become 0 because
Okay. But that's not a problem according to me. Machine didn't learn, that's all. Maybe my algorithm is wrong, I change the algorithm, it will learn. Okay. 1 is not a problem for me. Okay. I don't know how you consider 1, but look at the answer. Okay. So I'll before we go to the answer, I'll tell you with these two values. RK equal to 0.3. According to me, it is good for me because less error. Right? Machine has learned something 70% accurate. It's good, right? The other case is that RK is 0.7. 0.7 means it made more mistakes than the correct one. Again, it is okay because maybe the algorithm is wrong. I selected the wrong hyperparameters during the tuning or something like that. You make changes, it may improve. But what could be the worst case here? I want you to think about it. Not 0, not 1.
So 0.5.
0.5. What happens in the point if you put RK is 0.5?
That there will be 50-50 chances, na?
Yeah, 50-50 chances. What happens to the alpha? 1
So
minus
the alpha
0.5
will
by
be
0.5. 1 minus 0.5 by 0.5, right? 0.5,
Log
0.5
1.
cancels. It's 1. Log 1 is 0, right?
0.
Alpha becomes 0. Right. In the sense, next to all the data points will have 0 weightage. Correct? There is no meaning of learning after this. Right? Everything will get 0 weightage. There is no weightage at all. That is because there is one reason. Right? Whenever this alpha becomes equal to 0, we say that that's the worst scenario here. Can you guess why? You said 50-50, right? It's a right answer, closest answer. When you said that the chances are 50-50, what do you mean by 50-50 chance? I toss a coin and I say 50-50 chance, right? Means what is my question. I gave the tossing example just as an example, right? You can use it or you can think of anything else to answer my question. Why I said that RK is 0.5 is the worst scenario. Machine, you may think that machine has learned 50%. I said 30% is okay for me, but I'm saying that 50% is not okay for me. Why?
Because then we don't know where the actual problem lies.
Okay, closer answer. I'm looking for a specific some specific words, a specific phrase I'm looking for. Maybe you are closer to the answer. Your answer is pretty much close.
So
Anybody
the
else?
next time there will be no weighted set, na?
No, that's right. That's related to my next learners. I neglect all the next learners. I'm talking about the one learner which actually gave me 50% of this thing. I said that
Okay.
it's of no use for me. Though it has learned, I say that it has learned 50%. I say it is of no use for me. Okay. So one answer I already have got from my guest Swapnil, right? Try to modify that. I'm looking for a particular phrase. What do you mean by 50%? I gave an example of tossing a coin. Think of that as okay. What
So we
happens when
cannot-
you toss when you toss a coin and when I say chance of head equal to 50%, chance of tail is 50%? What do you mean by that? Right? Try to think that you can use it. Otherwise, anyway, you can think in your own way to answer.
It's a matter of chance.
Yes.
Yeah.
Can you say that it is random?
Yes. Sir.
Right? So it means whenever the machine, I said that RK is equal to 0.5, it means machine is making a random guess. That's all. Machine has not learned anything. 0.3 is okay for me because I can understand that machine did not learn. 0.7 is okay for me because I can understand that okay, 70% of the classifications are right. Machine has learned something. But this 50% has no meaning, no weightage at all because it is randomly guessing. True, false, true, false, true, like that. That's all, right? It's a 50% chance. Out of your 100 guesses you made, 50 are trues, 50 are false. 50 belongs to class 1, 50 belongs to class 2. What is the use of that? It's not correct, right? So that is why I said that's of no use. That is justified by your alpha k being equal to 0. No weightage for the learning that happens in the next cases. All right? Is that fine? Do you have any doubt with this? Please go ahead.
Yes, sir. Fine. Sir.
It's clear, right? Okay.
Yes. Sir.
So that's why
Yes.
this alpha value has a significance. That the reason why they have given a specific format that you see on the screen. This is eta into, right, a log of that term is brought for a particular purpose. All right. So that is the that's how the classification happens using the ADABOOST. All right. Let me quickly write the ADABOOST points over here. Right. There are two versions of the ADABOOST. You can even use the ADABOOST as a regressor as well, because the sklearn library has both versions of it. Like, though we studied the particular classifier, like a random forest as a classifier, you can see that there is a regressor present in that. If you want, you can still use it. Okay. So similar way, I'll write one point here. So that is the ADABOOST, right, has both versions of it, like classifier as well as the regressor. Okay, this is present in the sklearn. Okay, I'll give the brief coding, pseudo coding inside the sklearn, how to implement this. I'll come to that in a while. Okay. So again, each classifier, okay, inside this boosting can be, right, any ML, any machine learning algorithm. Okay, you can use anything over here, no restriction. But anyway, I think I have already talked about this. So you can use a logistic regression. So you can go for SVM, KNN, decision trees, anything you want, you studied so far, or anything you are going to study next, or which may not be covered in our course, but you will study by yourself. Anything you want, you can use it. Okay, so now I come to the name, right? Why it is called as a boosting? Can anybody answer now? We said that it is adaptive boosting. What you are boosting here? Are you making some changes as you move from one classifier to other classifier? Okay.
We are changing weight.
Yeah, so you are right using you are making the changes in the weight factor that is going to be multiplied for each of the data sample, right? So you are actually multiplying, right? That is what is itself refers to the boosting that happens. Okay, so I'll write if weight update increases the weightage of an instance, right? This itself is what is called as the boosting. Okay, boosting of those instances. Those instances you are trying to boost them up by giving more weightage. So that's the name. That's why the boost, it actually the boosting, irrespective of, there are many other algorithms also which comes under the boosting. Everywhere you'll see some sort of, right, boosting that is happening internally. Okay, right. Now, so let's come to the sklearn version. Okay, that is ADABOOST in sklearn. So there is the one version which we have discussed so far. You can consider that that's a binary version. There are two classes, and you are trying to build a model using this ADABOOST. But sklearn basically uses the another version of the same thing. It is called as it's a multi class version. All right, so the ADABOOST algorithm has a different name inside the sklearn. That's all. I'm going to give an explanation of that. So ADABOOST uses, the sklearn uses a multi-class version called SAMME. So that's the name of the algorithm. So that actually stands for, this makes the name itself makes many things very clear. Okay, so this is stage wise. A for adaptive, SAM for modeling. Then we have using, multi-class, exponential loss. So everything is very straightforward. We are e to the power, doing something e to the power. They are calling it as a e to the exponential loss. All right. So multi-class version of this, right? If we use this SAMME with only two classes, that becomes a binary class. If this SAMME is generally used, generally you can feed any number of classes to this as an input data set, then right, it's a multi-class. If you use only two classes, it becomes a binary class. Okay, then now there is a slightly modified version of this. Again, this was initially brought inside the scalar for a classification purpose, but each of the classes in the final decision, right? So I have say 500 different classifiers, and you see that the final decision is made based upon something like a weightage, correct? So in addition to that weightage, you can even bring in the probabilities into picture, because in one of the earlier discussions you have seen that something like voting happens, and you can bring the soft voting, hard voting. Hard voting is simply the majority. Soft voting brings in the concept of probabilities into picture. Same thing can be done here, right? For that reason, you will do a small variation. Okay, so that is SAMME. Okay, you will call it as a dot R. All right, so it uses the probabilities. Instead of simply taking a decision based on right the sum of the weights, you will use the probabilities into picture. Okay, so each of the class wise you can calculate a probability. You can accumulate the probability of each of the labels, and you can say that okay, this says that a particular label has highest probability. Cat has more probability than the dog, so your result is cat. Okay, that is possible here. So it uses probabilities. Okay, and most of the cases, again, this I cannot make a match and prove it here. Most of the cases, this SAMME.R performs better compared to the normal SAMME. Okay, and there is one more thing. As I told earlier, most widely used classifiers are the decision trees. Okay, so I'll make a point here also. You can use this when you do the coding, right? So this is usually, not always you can use anything, but usually in ADABOOST, right, the classifiers will be decision stumps. So decision stump, it's again a technical term. I want all of you to know this, okay? Because whenever you see some of the references, they simply say, okay, we have used decision stumps. So nobody understands what it is. That's why I brought it on purpose. So decision stump is a decision tree, but it has only one level, maximum depth equal to 1. Okay, let me write that here. Okay, so decision stump, that is decision tree DT with max depth equal to 1 is called as a decision stump. Okay, so all of them will be decision tree, only depth is only 1. Okay, so if you use like that, that becomes a the general ADABOOST, the most commonly used ADABOOST version, which uses the decision stump. All right.
So in SAMME.R, what's R stands for, or is just a naming convention?
It's just they have given the naming. There is no explanation for R. I didn't find it anything, but I'll search. If since you asked, I have to search. I'll search and I'll find out. If I get, I'll update you. You also search. Okay, if you get to know, please
Yeah,
update
sure.
me. All right.
Yeah.
As of now, I have never come across any meaning for that R. Okay, but maybe there is some specific reason because of which they have given a R over there. But I never found what that R so far. Okay, I'll find it. Okay, let's go to the coding part. This is how the code looks like, right? Okay, so you need to import, so from the sklearn dot, it's again, it is in the n symbol. You import ADABOOST classifier. Okay, then create a classification function that is equal to ADABOOST classifier. Okay. So what we do, we'll put the specification inside this. Okay, I'll open the bracket, but the next line I'll write here. So what you say, you will see, I need the decision tree classifier. So of specify, because it's a stump, so it's max depth equal to 1. Come on. Now you say how many such things, that is n underscore estimator. All right, so that is equal to any number that you specify. Last class I used 500, so I'll put 500. Then you specify algorithm equal to, now you specify, that is SAMME dot R, because we know that this is the better one. Okay, then in this case there is a hyperparameter eta. You can specify that if required, otherwise it will take it as a 1. Okay, so that is learning, I think, learning underscore rate. Okay, so specify any value. Normally any value between 0 and 1 is taken, so I'll say 0.8 should work. So that's what is ADA now. ADA underscore CLF dot do a fit. What do you do? It's X train and Y train. Now you know after this what to do. You can do a prediction. You can go for the calculation of various metrics, right? You can get a classification report is required, right? You have a lot of options. You can bring the curves, right? The AUC ROC curve if required, anything. Many things are there, but we will normally check the accuracy score. In addition to that, you can go for a accuracy score. In addition to accuracy, you can go for the recall, precision, F1 score, etc. Many things are possible. Okay, so that is the coding part that we will be using most of the time. Okay, do we have any doubts?
Excuse me, sir. Sir, I have a request, sir.
Yeah, please tell me.
So whenever you are uploading our notes, whether the PDF or the collab notebook, sir, kindly share the data set also, sir. Because sometimes we are not able to get that from the chat box.
Okay, no problem. Normally I share it, actually I'm not uploading. I just, after every session, I have to pass it to somebody from the academy. All right,
Okay,
so
sir.
they are the one who is uploading. Normally I send the complete package because everything will be saved inside my computer in a particular name. So I send the some complete thing to them, but I'll inform them once again, saying that you need to upload everything, don't miss anything. Okay, normally
Yes, sir.
maybe they think that only the whatever is written here is the notes and whatever is written in the class is the coding part. Mostly because
Yes,
of
sir.
they are thinking that way, they are uploading only that part, I guess. But normally I send everything to them. So I'll put a word, okay, to them saying that whatever I send, upload everything. Okay,
Okay,
I
sir.
can do.
Thank you so much.
Sure.
Thank you, sir.
Yes. Any other doubt or any other thing that you want to discuss? Okay, then we'll have. Okay, let's have a poll. Let's see how
So
much.
how many boosting models we're gonna learn? Like this one is adaptive boosting, and how many? Like
Only one. Because my intention is just to introduce you to the concept of boosting. Okay, once you know what it does, you can definitely refer, because there are so many options that I can teach. It's going to take a lot of time, but there is a time bound for us to complete the whole course within some time, right? So keeping that in mind, I will introduce you to each and every very important part of algorithm. Once you know what is happening here, definitely you will be able to extend your knowledge by reading other materials that you find, and that becomes very easy. Okay, the hardest part is what I'm trying to cover here. Okay.
Okay.
All right.
So if we learn the adaptive boosting, the other will be the same, but just a different method, right?
Yes, correct.
Okay.
Okay, so whatever we are teaching in our curriculum, in this case, maybe we will try to cover up, I think, SVM and the KNN, again, out of which SVM is outdated nowadays. Nobody uses that. But SVM, if I don't cover, people say that he's not covering SVM, and that's a big issue. So I'll cover SVM, but practically I'm saying nobody uses SVM nowadays. It takes too much time to learn, right? You have other, so whatever we have already learned, right, that itself is much faster compared to the SVM. So it's one more reason why people don't use it, right? Nowadays, as I clearly said, it is outdated. But anyway, we'll discuss that. We may not be implementing that and all, because already we have called the function in the previous session, and you know how to implement. Implementation part will not do that. We'll just discuss how it works. Okay, so SVM and KNN are left over here. So maybe I'll try to cover it in the next session, so that we can wind up with this particular module and we can go ahead. Okay, yeah. So meanwhile, please answer these questions. Okay. All right, so answers are pretty straightforward. This is a very simple quiz. Okay, so those are the two answers, and I'll quickly finish within the next 2 minutes. All right, and let me go back to the first part. You see here. So initially we said that, right? ADABOOST is used for classification, right? Very similar to the ADABOOST. One more name, since I have taken the name here, that is the gradient boosting. Anyway, it's pretty much straightforward, and you can definitely explore by yourself. But let me give one or two inputs here. Okay, so that is, right, I'll just write the name. Okay, that is gradient boosting. So initially when we discussed, we clearly mentioned that this is one type of algorithm that is used if you are performing a regression. Right, now for a classification, you had used the misclassified data samples, you updated the weights and used it for the next case. But now I'm not doing the classification, right? So I don't have a data to classify saying that this is a correct answer, this is a wrong answer. I don't have it. Correct. What do you do? What will be used for the next learner is my question. I'll answer that and we'll wind up. We'll discuss that just for 1 minute. Okay, anybody? What you can use? I have many models available. I'm doing a regression. So you see that I don't have a data set to say that this data is correct, this is wrong. I don't have it. So what you can use, so that you can use a particular parameter that you have to use for the learning of your next learners that are present inside this gradient boosting. What do you think? What you can use, right? Well, just answer that.
Average, sir.
Sorry, average of what? Okay, maybe average may work, but what average of that? Because there is no
Oh.
classification happening. If classification happens, you can say that, okay, this particular data set is wrongly classified. Do something with that. That's what we did earlier in the adaptive boosting. So what happens in the subsequent predictors? Are trained on the errors. You have because when you did the regression, there was no misclassification. You had to take a error, sum of the error, mean squared error, right? Residual error. Many errors were there. So any of the error you can use. Okay. So based on the errors made by the previous predictors. Okay, so that's the only thing, right? What happens, I'll quickly try to write one small diagram for you. So there is a classifier. Okay, this is not class, this is a learner. Regression happens over here. So you give your x as input, it actually generates a y cap, your prediction, right? And normally you calculate error. Error is equal to magnitude or squared error of y minus y cap. This happens over there. You take a magnitude. So for your second classifier or second learner, you give your x and you will use the same thing. That is right. I call it as y1 cap, right? So you have to provide the y minus y1 cap. That is that what is this? Y minus y1 cap. That will be given here. That is used to calculate your y2 cap. So y minus y2 cap will go to as an input in addition to the actual data. So that will be used to learn this. That is y3 cap and so on. This repeats. Okay, so that's the overall big picture, right? And anyway, implementation is very straightforward. We can simply call that XGBoost inside the scikit-learn and can be implemented as straight as possible. Okay, so just a big picture. Our intention was to cover only the ADABOOST, but since there was a little bit time, I thought let me cover that way as quickly as possible.